Hey folks, welcome to Module 4, and this is the first video of Module 4. And in this lecture, I'm going to explain you, alright, we are going to dig deeper into the concepts of marker-based augmented reality. That is, we are going to learn about the architecture, we are going to learn about the available SDKs, we are going to learn about how things work in marker-based augmented reality. Alright, and later on, I'm also going to tell you what means how like which tools are we going to use to develop our like AR applications, right? So without any further ado, let's get started. So what is, see, first let's recap. All right, first let's recapitulate our concepts of marker based augmented reality. All right, see, marker based augmented reality, all right, this is a type of augmented reality, all right, that makes makes use of recognition and tracking. All right, it is the property of or you can say it is the feature of computer vision. All right, so it make uses the properties of computer vision, that is tracking and recognition, all right, to recognize and track a marker and put, all right, and place or augment a 3D object or any kind of digital objects on top of that marker, right? You can even augment a video on top of that marker. So that is what marker based augmented reality is. All right. So yeah, that is what marker based augmented reality is. You can even see the diagram, right? It's not exact diagram but the gif, right? In here there's a mobile and there are some a b c d are written, some alphabets are written, and they are working as the marker, right? In the center marker, the Batman is, like the Lego form of Batman is placed. So this is what marker based augmented reality is. It basically makes uses of markers to augment, all right, to place digital objects into a real world. That's just it. All right. Now if it see, we already know what a marker based augmented reality is. Now it is our a very time, all right, it is our time to understand or learn about different types of game engines, all right, different types of development engines available. All right, if we talk about, there are multiple available in the market. All right, these are just some of them. All right, I have just listed down some of them, but there are many others available in the market. All right, if we talk about the things, the engines that are available here, that is Unity, Unreal, Godot, a Cry engine. Then if you want to develop your own AR filters, let's say for you want to develop for Instagram or Facebook, right? There is Spark AR Studio I am going to cover in this course also. So this is the bonus section. All right, in the bonus section I'm going to cover the Spark AR Studio. Similarly, if you are a user of Snapchat and you want to create your own filters for Snapchat, then there is Lens Studio. All right, these are augmented reality technologies. All right, then there is Apertus VR. Although I haven't used Apertus VR, the engines that I have used till now, all right, the development tools that I have used till now is Unity, Unreal, Godot. I have tried out CryEngine, but it wasn't suited for me. I didn't like it. So, and another I used was Spark AR Studio. All right, I haven't used Lens Studio or Apertus VR, but you guys can try it out. All right, so these are the development engines that are currently available in the market, and the most used, all right, in the field of augmented reality and virtual reality and mixed reality, the most used is Unity. All right, like the major companies uses Unity for developing AR VR applications. Unreal Engine also is also used. So these two are the main, like, major development engines that are used. Even Godot supports AR VR. You can try it out. Same does CryEngine too. They also support AR VR. All right, so you can try these out. All right, and in this course I am going to teach you Unity. All right, and we are going to cover the AR part with Unity. All right, so as we have learned about the development engine, now it's our very time to learn about the software development kits available. All right, here you can see there are multiple available, like Google's AR code, then there is Kudan, then there is Apple's AR kit, then Maxt is there, then Vuforia, 8th Wall XR, then Lightship ARDK, then Easy AR is there, and Wikitube is there. All right, see, these are software development kits, that is SDKs. They come in packages. All right, they come in packages. All right, and in this course I'm going to cover the Vuforia. All right, I'm going to cover Vuforia. as Vuforia is very famous and very good for marker-based AR, and it is also easy for beginners. So it is better to cover Vuforia in this course. So I'm going to cover Vuforia, all right, and the tracking feature of Vuforia is better than any of these. All right, means better than any other marker-based AR technologies. All right, so that's why I'm going to cover Vuforia in this course, and also if I tell you which SDKs have I tried. I have tried out AR code. I have developed multiple apps with it. I have tried out AR Kit, that is Apple's. Then I have tried out Vuforia, of course. Then I have tried out Ethwal XR, although I didn't liked it much, but it's decent enough. All right. Then I have also tried out Niantic Lightship AR. All right. It has just launched, like it has launched on 8th of November. Currently it is in beta. All right. You, if you want, you can go through the documentation and download the SDK and try it out. All right. So Niantic has launched their own Lightship SDK. Niantic is the same company who developed Pokemon Go. All right, so they have released their technology behind Pokemon Go on the like publicly. So I would suggest exploring the Lightship AR DK. All right, and yeah, I have tried these. All right, but if you want, you can try the others also. Like you can try out Kudan, you can try out Max, you can try out Easy AR, Wikitude, and all these available in here. See, these are not just all right. Means there are many others also. All right, like I haven't listed all of them, but there are some of them that I have listed. All right, so try to do some research. All right, do a research by yourself and find out what more SDKs are AR SDKs are available in the market. All right, so yeah, these are the SDKs that are available. And in the development tools, all right, in the development tools I'm going to use Unity. All right, I have already taught Unity, and in module 2, and in module 4 I'm going to teach you Vuforia. All right, so we are going to for this course we are going to cover this whole course in Unity and Vuforia. All right, so yeah, let's get dive into the concepts. All right. See, what is recognition? All right, what is it? Think of in human terms. All right, just think of in human terms. See, a person is coming to you. All right, he is the person is your relative. All right, you know the face. All right, it is stored in your brain. All right, the face of that person is stored in your brain. Now you can recognize that person, right? You already know that, right? You already know that. So that's how you are recognizing, right? That's how you are recognizing the person. Yeah, this person name is ABC, and he works at this ABC company and this and that. All right, you know that person. You are able to recognize it. Similarly, if you think about devices, all right, let's say barcode devices, right? See, if you buy any sort of product, all right, let's say we go in a mall. When you buy any sort of product, you submit it in the counter to make the bill. All right, what they do, they have some sort of reader, right? Exactly don't know the name. I think it is called barcode reader. So what they do, they with the help of the device, they read the barcode, all right, and then push the object or the thing that you are buying forward, right, and make the bill. So how the device is recognizing the barcode, right? Because uh, the device already knows, like it already has the data about the barcode, right? It already does have the data, so that's how it is recognizing it. So like I have bought let's say I have bought a pair of shoes, all right, and there is a barcode. The person, I have submitted in the counter, the person scanned the barcode and pushed the shoe forward to for the billing. All right, so the particular barcode is stored on the database. All right, so that's how the barcode reader recognized it. Similarly, if we talk about face recognition system, same thing works. Like in big companies, they use face recognitions also to verify the employees, right? They use fingerprint recognition also. So these are stored in the database, and some algorithms are there. All right, there are some algorithms, some computer vision algorithms which are able to recognize the person, right? Similarly, in AR also there are some sort of databases. All right, in marker based AR there are some sort of databases. Databases, in the sense, they are markers. All right, those markers are stored somewhere, right? Those markers are stored somewhere, and our app, and we design our app in that way. All right, in a way, we design our app in a way so that it can recognize, all right, it can recognize the marker. If the marker isn't in our database, then it won't be able to recognize it, right? And if it is not able to recognize it, then how would then how will it put the marker, how will it put the marker on top of that mark sorry put that object on top of that marker, right? How would he do that? How would the algorithm, how would the SDK do that? So it is always important, all right, to whenever working with marker-based AR, we have to put a marker on the app's database. And don't worry, we are going to see how this is done. All right, there's a very basic of Euphoria only. So yeah, so that's how recognition works. All right, in marker-based AR, and this process is valid in multiple ways, right? So this is what recognition is. Recognition is basically recognizing something, all right, that is in the database, like in our human mind. All right, if I see a person, I might know the person, right? I know my brother, all right. He's a person that is in my brain's database, right? I know that person, so I will be able to recognize it. All right. Now let's say some new person come. All right. I won't be able to recognize him, right? I won't be able to recognize that person if it was a random person, because I don't know the person. His details aren't stored in my database, right? So these things work something like this. All right. So yeah, this is what recognition is. Now, if we talk about tracking, all right. See, this is a image, all right. This is the image of Ganesha, Lord Ganesha, all right. And in here you can see multiple plus, right? You can see multiple plus are there. Do you know what is this? These are basically the trackers, small trackers. Means these are feature points, you could say. All right, these are feature points of the image that help us tracks. All right, that helps tracking the marker. All right, that helps tracking the marker. How this help? See, basically whenever we upload a database, all right, in our database system, all right, in Vueforia's dashboard, after you have uploaded your image in the database, all right, you can view the tracking points. All right, this is the image from Vueforia only. I means I uploaded this image on the database so that I could get the feature points. All right, I will show you how to get that feature point, how to see the feature points by yourself, right? In the next video only. So these feature points, all right, these are some sort of patterns, you could say. All right, see, the tracking, all right, the tracking technology, all right, in AR basically finds, all right, they try to find some sort of pattern. All right, these feature points are useful for tracking and recognition. All right, uh, means, see, if the how would see if I had to give an example. All right, you have created a marker. All right, you have successfully placed, all right, you have successfully placed the digital object on top of that marker. All right, you have successfully placed the digital object on top of the marker. Now, how do you think will the, like, if I move my marker onto let's say 10 units to the left side, all right, how do you think the object will also move? Because yeah, it is recognizing the marker, right? It is recognizing the marker, that part is done, and it has been placed on top of that marker. But when we will move our marker from one place to another, all right, how will the digital object move? Can you think of it? That's where the tracking helps. All right, how it helps? See, you can see the feature points, right? Here are the feature points, and these feature points, all right, these feature points helps the marker, all right, helps the app to track the marker, all right, to keep the marker in track, and also move the particular digital object along with the marker. If I am moving, all right, if I am moving the marker to the left, all right, let's say I have moved 10 units to the left, all right, the same thing will happen with the object also, because the marker has moved, all right, and our app has tracked that the current position of the marker is 10 units from the center, right? So our what our app has done, it has tracked and again placed it in there, all right. Although if you try to move it, the object will also move with itself. It will be a smooth, like it will be really smooth. So that's how tracking is. Tracking helps in marker based augmented reality, all right. So tracking and recognition, all right, these two are very fundamental and important technology of marker based augmented reality, all right. So yeah, I hope you have understood that what is recognition and what is tracking and how they are helping in a marker based augmented reality, all right. So yeah, the same thing it is written here, marker based augmented reality makes use of both recognition and tracking, all right. And you and now you know how it makes use of them, right? Why it makes use of them, what is the use case of them, right? You know right now. So also, before moving to the next section, all right, so do subscribe my channel, all right, because it helps me to bring more videos, all right, more courses for you for free, all right. And also join our Discord community, all right. And if you have any doubt, all right, if you have any single doubt, join our Discord community. You can ask in there. We will be helping you in there. There are many like-minded people who will, if I'm not available for some time, then they will help you to figure your doubt. So make sure to join our community, and if you have any doubt, you can ask in there, all right. I would like to help. And also, if you can even comment, all right, comment down in the comment section that what your doubt is, and I would clear that right in there, all right. So now our here is our another topic, that is marker design detection and recognition, all right. See, this is a very basic fundamental thing, all right. Now there are colorful markers also, all right. But to make you understand, I have taken example of black and white marker, all right. See, basically, majorly, all right, many people prefers to use like black and white markers, something like this, all right, which are basically square shaped and are black and white, like uses black bordered images, and also like the image inside those black borders are black and other are white. So basically what it does, right? See, this type of images, all right, this type of images helps in image unwrapping, all right. uh, Here you can see that this is a bird, all right. This is a bird, all right. After the image unwrapping, all right, after the image unwrapping technology is applied, here you can see like in this image, all right, from this image, the face, all right, the white borders are there, and here is the face. The face has been unwrapped from that whole sorry, black borders, right? So here you can see the face has been unwrapped and it has been positioned like this. The similar thing will happen with this bird also, all right. It would be unwrapped, all right, this image would be unwrapped, and then it would be placed like this, all right. This would be the main image. So this is how image unwrapping works, all right. And image unwrapping is also a very important concept. Similarly, here you can see this is a like many people use this, all right. And it this black and white image makes it easier for the algorithm, all right, makes it easier for for the algorithm to do the detection, to unwrap the image, all right. But there are many powerful algorithms that have been designed, and they can efficiently extract, or you could say unwrap the images of unwrap the color images also. So that's why we can also use colorful markers too, all right. So yeah, and even if you notice, all right, if you go to let me show you in here also, all right. Here you can see uh, the marker, all right. I have already told you that this is the marker, this is the image of the marker that I have uploaded on Vueforia's database, right, for marker based tracking. as you can see, the image has been like, the texture of the image has been is really low, right? The quality of the image is really low. It has been pixelated. You can literally count the pixel if you want. All right, although it would be hard because there are lakhs of pixel in there, but here you can see that the image has been pixelated, the quality has been lowered. All right, the image is distorted. All right, that's how it helps to track, right? That's how it helps to track. It tracks pixel by pixel. It This things helps to unwrap the image also. So that's how marker image unwrapping works. All right, it unwraps the mean particular portion from the whole image. All right, so now it's our time. All right, it's our very time to understand AR system architecture. All right, see, if you understand the architecture now, you can even create your own AR SDKs. All right, marker based AR SDKs, although that of course won't be easy. All right, because before developing any sort of SDK, you need to have a good amount of knowledge of computer vision. All right, because see, augmented reality was built upon computer vision only. It is you could say a product. All right, or you can say it is a technology of computer vision only. If computer vision wasn't there, then augmented reality also wouldn't have been possible. So computer vision is the root. All right, it is the root of augmented reality. So it is really important. See, if you want to create your own AR SDKs, all right, if you want to create your own AR SDK, you need to have a good knowledge of computer vision. You need to know the algorithms. All right, even I am learning computer vision for augmented reality, so I can get a more deeper understanding of how these things work. All right, I have a currently I have a decent understanding. All right, I understand how these things work, but I don't know how to develop these things. All right, what algorithms are used. So for that I need to learn computer vision. So I'm also learning that. So it is very important for you. All right, if you want to develop your own SDK, you have to learn computer vision. All right, so without any more talk, say let's start with understanding the AR system architecture. All right, see, in this architecture you can see there is a camera. All right, then from the camera the image is passed. All right, image is passed to the tracking module. All right, some things happen in there. All right, we will understand what things happen in there. All right, then it is passed to the rendering module, where the real world and the virtual objects are combined in the rendering module. All right, and the augmented output. All right, the output is passed through the rendering module to the display. All right, so this is how it works. You can see the diagram. All right, like if I had to show you like this. All right, uh, pen. First of all, it is moving from here and there. Okay. Then from here it is going to here. All right, then from here it is literally going to the rendering module, and this, all right, this virtual module is adding. All right, this virtual module is adding to the real world component. All right, sorry for this bad handwriting, but this is RC, means real world component. All right, and real world component, sorry, virtual component and real world component are like actually attached. All right, the real world the virtual component is attached to the real world, and then the output. All right, then the output is generated, that is the augmented image. All right, and after that it is being displayed in your system's display. All right, so this is it. That's how it is working. All right, now if we talk about understand the module. All right, see, if we talk about the you already know what is the camera, right? What this camera module does, right? Because it renders, like it renders the image of real world, all right, into your phone. That's what a camera does. But what is a capturing module? All right, see, the things that you see from your mobile camera, all right, you can even capture it, right? You can even capture it. So through the camera some sort of image is passed to your display. All right, and when you click on that centered button available in your mobile camera software, when you click that, it is captured, right? So the capturing module basically helps to capture the image. All right, basically helps to capture the video or the image. All right, So this is what capturing module does. Now if we talk about the tracking module, all right, see, the tracking module is the core. All right, the tracking module is the core. And if we talk about see, how tracking module works now, it calculates, all right, it calculates the pose, all right, of the camera, all right, in the real time, all right, like it will calculate where your camera is. And if I talk about FOVs, all right, that is 6 degree of freedom, it means that you have a freedom of to look anywhere, all right. This is a very basic definition of 6 DOFs, all right. See what this term pose does. Let me tell you. Pose estimation, all right, basically helps to get the orientation and location, all right, get the orientation and location of a particular object. This is what the tracking module does. All right, it is basically the code. All right, it helps to calculate the pose of the camera. All right, in real time. It's not like it will only capture once, then it won't do it again. It happens in loop. So the pose estimation is done, and also because of that we get the 3D location, or you can say the orientation of any sort of object. That is the work of tracking module. All right, if we talk about the rendering module, all right, see, what this rendering module does is basically it combines, all right, it combines the digital object, all right, it combines the digital object with the real world visual, all right, with the real world image, right. If you have used any sort of augmented reality, you might have seen that, right, that some 3D object is appearing on sort of on any marker, right, on an image, a 3D object is occurring. So basically a virtual component is being attached with that image, and then it is being processed and pushed forward for the display, all right. And if you are confused, all right, if you are confused about these modules, don't worry, all right, we are again going to look into another, all right. This is a much more simplified version, all right. This is a much more simplified version of that AR system architecture. I have included this because I thought that for the first iteration, I think people will get confused that how this, like, what did I explain to you? You might not understand it, right? So I have also included another architecture. All right, the same thing happens in here also, but I will re-explain it. See, in here, all right, a live video feed, all right, is going through the camera, all right, to the image capturing module, all right, and it is, all right, and it is divided in frames. The video is divided in frames, and then it is going through the image processing module, all right, and in there the marker is detected and tracked, all right. Means in there the marker is detected, actually all the processing is done, all right, all the pose calculation is done, and then we go to the marker tracking module, all right, where the pose calculation is generally done, and all the tracking stuffs are being done in there only, all right. All the what can I say, those virtual points, right, those feature points are applied in the image in there only. The pose calculation is there only. See, if you are confused about pose calculation, don't worry, all right, let me explain it to you again. See, pose calculation is basically, it calculates the position, all right, it calculates the position of any object, all right. That's what pose calculation is. It calculates the orientation of the object and the location of the object, all right. So that's what pose calculation is. And then after all these processing and tracking is done, it is passed to the rendering module, all right, the virtual object, all right, the virtual object that we want to augment, all right, that we want to augment is combined with the real world image, all right, the virtual object is combined with the real world image. Then then it is passed to the display screen, and we actually see the output on our displays. So that's how this AR system architecture works, all right. I hope you are clear with the concept, right. Again, the same definitions, all right. the image capturing module that takes the images, it breaks it to frame by frame, then and all those things that are being done. Then there is image processing module. All right, the processing that are being done. All right, means the detection, or you could say the recognition techniques are being applied in there. All right. Then if we talk about the marker tracking module in there, the position is being calculated. All right, the position is being calculated, and then feature points are provided, and the rendering module. All right, this rendering, what this rendering module is doing, this rendering module is basically uh, combining the virtual object to the digital object. This is just it. All right, it is doing that, and yeah, that's it. So that's it for our today's lecture, and I hope you have understood. All right, I hope you have understood how all these things work. All right, I hope you have understood how the marker-based AR system architecture works. All right, so I don't think now it would be any problem, as you have as I have cleared all the very basics, or the very basics of marker based augmented reality. Now I don't think it would be any problem learning marker based AR development.